Welcome to Quantum Physics for 5, where we delve into the fascinating topic of entanglement, also known as quantum entanglement. At the heart of this phenomenon lies the mysterious connection between quantum particles, which seem to communicate instantaneously across vast distances, defying the laws of classical physics. In this video, we'll explore the history and significance of entanglement and how it's paving the way for revolutionary technologies such as quantum communication and teleportation. So buckle up and get ready for a mind-bending journey into the quantum realm. Quantum entanglement is one of the most confusing and profound aspects of quantum physics. Theories about this phenomenon have been around for almost a century, but scientists are only just beginning to understand how it works and what its implications are for our understanding of space, time, and causality. In this article, I'll show you some basics about quantum physics that will help you understand why certain questions in quantum physics seem impossible to answer and why they are actually quite simple. What is entanglement? Entanglement is a quantum phenomenon, and it's not just a curiosity anymore. It's the key to quantum communication and teleportation, the ability to send messages from one place in space to another without using any wires or equipment. What is entanglement? The Copenhagen interpretation of quantum mechanics says that when you have two particles like photons, they must always be linked together at every moment in time. Otherwise, there would be no meaning behind our language of physics, which relies on probabilities rather than certainties. But this doesn't seem right. If you want your car to go faster, for example, why don't you just put some extra gas in each tank? The answer lies with entanglement. If two photons interact, say by bouncing off one another, then their wave functions become entangled and remain so until they're measured separately again. How does it work? The phenomenon of entanglement is a quantum phenomenon. What does this mean? According to the laws of quantum physics, two particles can become entangled if they're linked together by an instantaneous connection, a phenomenon known as superposition. This means that two particles will behave in ways that seem to be determined by each other's behavior at any given time. For example, if one particle absorbs energy from another, say from the sun, then its own energy levels may be altered by those absorbed photons. Likewise, if another particle absorbs energy from you, say via radio waves, then your own level might change due to this absorption event as well. The result: when these changes occur simultaneously over time within separate groups of atoms or molecules in different locations around us, like our brains, they create what's called entanglement between pairs clusters of atoms or molecules at different locations on Earth's surface, including everything down here below us on Earth itself. Everything up above too. Does it violate causality? The answer to this question is yes and no. It does violate causality in that it cannot be described by classical physics, but it does not violate causality any more than ordinary non-quantum entanglement does. The distinction between quantum and non-quantum entanglement can be illustrated through an example from classical physics. A bunch of particles are entangled, meaning that their properties are linked together at some level despite being separated spatially. If one moves away from the other particle, then its position becomes uncertain. In contrast, quantum mechanics describes how two particles interact with each other. Even if they're separated by huge distances, they can still influence each other even though they're far apart. Does it violate the Einstein-Podolsky-Rosen-Eper paradox? The Eper paradox is a thought experiment that was first published in 1935. It demonstrates the possibility of non-locality and quantum communication, as well as teleportation, by showing that you can send information faster than light. The problem with this experiment is that it violates Einstein's special relativity principles, which state that nothing can travel faster than light 186,282 miles per second. This means that even if two particles are entangled on Earth and one goes over to another planet where the other particle lives, the two will never be able to communicate because they'll never be in sync with each other again. Can you apply entanglement to communication and teleportation? If you're a fan of Star Trek, you're likely familiar with the idea of teleporting. It's a common trope in sci-fi, traveling across space without having to go through any planets or stars. But why can't we do this today? The answer lies in quantum entanglement, a phenomenon whereby two particles become linked so that each particle becomes part of a single entity that exists as an interconnected whole, the classic example being Schrödinger's cat. Quantum physicists use this effect to create entangled pairs of photons and electrons, which then act as quantum channels for communication over long distances between 2 points on Earth or even beyond Earth's atmosphere into outer space itself. This means it might be possible to teleport objects from one place to another on Earth, using only light as your signal. But does that mean there'd be no way for us humans anymore? No thanks. In order to use entanglement, we will have to reconsider our understanding of space and time. In order to use entanglement, we will have to reconsider our understanding of space and time. In quantum mechanics, a quantum state is defined as a physical system that has both matter and energy at the same time. A particle can be in two places at once, or more. This means that if you observe one location of your particle with an apparatus like an atom interferometer or laser trap, it might be found somewhere else entirely. In this way, physicists have demonstrated that entangled photons can be sent through space at speeds faster than the speed of light, a phenomenon known as superluminal communication or teleportation, though technically teleportation involves transferring information from one place in space-time to another. As I mentioned earlier, entanglement is a very interesting subject. It will take some time for us to understand how it works and what its implications are for quantum mechanics. What we have already learned in this video should help us get started. Thanks for watching. I hope this video has helped you understand the fascinating world of entanglement and its potential for revolutionizing our technology and communication systems. Don't forget to like and subscribe to stay updated on future videos, and please leave a comment if you have any questions or feedback. Thank you,